Welcome to session one of the integrated grid planning. And this session, we're going to focus on reducing the need for conventional capacity upgrades. I know it's after lunch, right? It's not right after lunch. Right after lunch, you might have still been awake. Now it's probably when you're starting to fall asleep. So hopefully we'll get you all going and get some good questions and some good dialogue going in this session here. First, I'd just like to introduce So I'm Satvir Nagara. I'm the Senior Director of Asset Planning here at PG&E. I have a team that is responsible for all the T&D planning as well as the generation interconnection. And with me, I also have Jocelyn Wong, who is the Senior Manager of Integrated Grid Planning. PG&E has experienced minimal and localized load growth across our system for the past 40 years. Today, the electrification of transportations, buildings, and industry has resulted in a paradigm shift that will increase the demand of electricity by an estimated 70% over the next 20 years. You know, as we heard in the morning sessions with both Patty and Leland, right? Capacity is going to be needed, right, in the system. The electricity need is going to grow a whole lot, right? So this presents a challenge, but also a tremendous opportunity, right? The tools of today were designed to safely connect new individual loads in a steady growth paradigm and will not be capable of supporting the widespread, rapid changes that will be needed across our energy system. Today's load growth provides an opportunity for transformational investment to refresh and reinvent the grid and to create downward rate pressure if load growth can be accommodated cost effectively. The 2022 Integrated Energy Policy Report released by the California Energy Commission shows a considerable increase in load forecasts over the coming years. Demand is anticipated to grow more than expected, even when compared to the most recent estimates in 2019, driven by transportation trends, rising temperatures, and system transition in compliance with California's climate targets. Given the scale and pace of change, PG&E is seeking a broad portfolio of innovative solutions to help transform our grid. We are seeking novel solutions and technologies that can safely maximize the utilization of existing infrastructure to defer or avoid conventional capacity upgrades altogether. We recognize that in many cases, conventional capacity upgrades will be unavoidable. Where that is the case, we are seeking technologies that can help us make the right investment at the right place at the right time. Additionally, we are looking for tools and technologies that will enable us to minimize the cost of these conventional upgrades and maximize the reuse of existing infrastructure that still has remaining safe and useful life. In this session, we'll be diving deeper into the first category of solutions and discussing the challenges of the conventional upgrades that we are seeking to solve for through novel solutions and technologies. Granted here, when we're talking about, the assets, we're talking about the transmission system, we're talking about the distribution system, we're talking about substations, right? It's all those assets. Jocelyn will now discuss challenges of conventional upgrades.
Thank you, Satvir. I'm Jocelyn Wong, Senior Manager for Integrated Grid Planning. So as Satvir mentioned, there are the unprecedented load growth is really going to essentially create a bunch of opportunities you have for electric systems, especially from an investment standpoint. However, recognizing there are technologies of how we can better do this, we're still going to have to do conventional upgrades to our electric system. That being said, there are a number of challenges that we currently face with conventional upgrades. It's the cost of upgrades, we have permitting requirements, space constraints, community resistance, not just to mention just the pace of load growth that we're seeing. It's really hard to keep up. And so this is where we are looking to you guys of how how can you guys help us? Right? How can we think about reducing the cost for those upgrades? How can we think about reducing the turnaround time for those? Essentially, and how can we minimize the need to replace assets before their useful life may be over? And so, oh, sorry, I need to speak a little bit closer. Apologize for that. Basically, we're looking for help and how can we make it easier and quicker for us to really interconnect loads to our system? These are customers. So next slide, sorry. Next slide that we have has some ideas of some potential opportunities, but I'm sure you guys have many more that you'll be sharing with us of what we can be doing. So PG&E has millions of assets that we currently utilize to serve our customers. But really, there's more we can probably do with them. This is where we need your help. Right, there's a wide range of technologies that could provide transformative impact, enable PG&E to safely maximize the utilization of our existing electric assets and infrastructure. So these could include how do we increase the ratings on those assets, the thermal ratings? How can we improve voltage, performance, efficiency of those assets? And then another piece of this is how can we utilize the footprint that we currently have? How can we potentially augment those existing assets in their current footprint, or how can we reutilize that footprint for other things? And so that was a lot to throw at you guys. But overall, just to recap, we're really looking, how can we best maximize the use of our existing assets and reduce the cost of our capital improvements? So I think with that, I don't know if that was 15 minutes, but I really want to give you guys time to ask questions. So we do have a mic runner in the room. So if you want, you can raise your hand. I know online, there's a bunch of folks that you guys are joining us as well. If you put your questions in the chat, we'll get to those as well.
So we'll be taking 2 audience questions and then 2 online questions. So I'll start with the gentleman in the back.
Hey, thanks for that short one. That was really good. Just a quick question. Are you kind of thinking hosting capacity and hosting capacity management? Are there kind of things that you're thinking about around maximizing utilization? Just wanted to ask that question. Or are you even familiar with that in terms of distribution, hosting capacity management?
No, we're familiar with the hosting capacity, but what we're looking at is, how can we utilize the existing assets we have to their maximum potential, right? As well as if we do need to do upgrades, how can we minimize those costs of those upgrades?
Okay, thank you.
There was a question.
Hi, I'm Farouk Albuye from OATI. Are you considering dynamic hosting capacity calculation and dynamic operating envelopes and active DER management as a means to increase utilization of existing facilities?
I mean, that could be one approach to it, right? We want to make sure that we can maximize the existing assets while we minimize what we need to build, right? So we can serve more load, get more out of what we have in the ground today. So that could be one of those ideas. So we're open to any ideas you all have, right? That's the whole intent of this, is what ideas do you have that allow us to maximize the use of what we have today that allows us to serve more load, right? At the same time, if we do need to do upgrades, which we know we do, and we're not going to meet the 70% without doing any upgrades, but how can we do that in a cost-effective manner, and how can we minimize the cost of those?
Do we have any online questions?
We do. The question from Roger Reinhardt: would real time mean sub 1 second detailed frequency and phase maps help with capacity planning?
Can you repeat that one more time?
Sorry, would real time detailed frequency and phase maps help with capacity planning? Real time meaning sub 1 second.
So are you talking about on the distribution system? In what way are you talking about?
It doesn't indicate, sorry. We'll move on to the next one.
Yeah.
This is from Daniel Wolf. To what extent do DERs play a role in reducing the needs for conventional capacity upgrades?
I mean, DERs definitely have a role in that, right? I think that was mainly covered in the load management and load supply sections, right? But of course, DERs, we currently have DERs on our system today, and they are helping us in serving loads, right? But we do have the issue of, PV is during the day, when the sun goes down, there is no PV, obviously need for additional battery storage and other technologies to help during those peak times, shifting behaviors of when people charge. I think all those are on the table, but a lot of those were covered in some of the other sessions. Really, the idea here in this session is to focus on, are there ways that we can look at our existing assets and can we increase the throughput by doing something? So just to give some examples, right? Our 4 kV system, is there a way to cost effectively upgrade the 4 kV system when we need to upgrade the 4 kV system to a higher voltage level, right? We have in our urban areas, we have underground circuits that are in duct banks or multiple circuits in the same trench that due to mutual heating, the rating of those conductors is reduced, right? Is there a way we can deal with that to increase those ratings so we get more out of those existing assets that are there? Our assets and substations, is there a way to get more out of those substation transformers or those buses or those breakers that doesn't require complete replacement at this time, right? How can we maximize what we have out there in our grid, from the transmission system to the substation to the distribution system, that would allow us to just get more throughput with the existing system? But when we do have to do upgrades, is there a way we can minimize those upgrades based on some of the things that Jocelyn talked about, right? How long it takes us to do a project, what are the permitting requirements, all those things that we have to overcome. Are there any ideas around that?
Hi, Eli Anderson with NERA. For something like a line re-rating project where you're looking at the thermal capacity, it requires pretty accurate levels of identifying what's present in the distribution transmission network. Is there a portion of this plan that incorporates increasing the accuracy of your current models of the system that would allow you to do that re-rating to identify that change? Or is that a separate question for a different type of project?
We're going to talk about how we can improve our planning processes in the next section, if you
Okay.
stay for that one. But it is a good question of how can we take the data that is available and make better use of those to inform how we can operate our assets. So I don't think it's necessarily out of scope, but it's something, it's definitely an idea we'd be willing to discuss.
Liang Min, Stanford University. Actually, if I'm allowed to ask 2 quick questions. One is that we heard this morning optimization coordination are very important of DERs, as Patty mentioned, right? But when you do the integrated planning, how do you exactly model this optimization and coordination into your planning process? I think that's a key. How do you model optimization in your SIMDisk software, right? Do the distribution planning. Another follow-on question to this gentleman is really, you also mentioned the transmission, substation, and distribution. They are all modeled and planned separately. PSLF, SIMDisk, etc. But they are all in one system. The DER can participate in DERP for the CAISO. Is there anything PG&E think about to do the integrated holistic transmission distribution co-planning process?
Obviously, right, that's where we need to go. We're looking for those ideas as well. How do we do that holistic plan from distribution all the way up through the transmission, right? We're looking at doing that. That's going to be something that's needed, right? We have some tool upgrades we're doing internally, but we're looking for other ideas. That's, what ideas do you all have that can help us do that?
Is there any online
Yes. So, question from Robbie C. Pathy is temperature management is key to avoid upgrades. We have a fiber-based temperature system that provides thousands of real-time data per minute. Currently being used in MV cables in USA's, pardon me, Canada, can also be used in large other assets. That is not a question, but you can address it if you'd like. Nope, okay. Is PG&E implementing or considering implementing grid enhancing technologies to increase capacity on existing lines and circuits?
Yeah, I mean, we're looking at it. We're installing sensors. We're getting that sensor data back into our systems to look at, condition of the grid. We are looking at dynamic ratings. We are looking at all those things, but we're open to any ideas folks have that may help in that endeavor.
Hi.
This is Jan Griggy. I just wanted to add a little bit to the question about optimizing the grid at the transmission, distribution, and sort of customer level. And we are actually starting a project to do exactly that. And it's important because, if you know the duck curve, right? The duck curve is at the grid level, it's a really deep belly. At the distribution level, it's not as deep. And so you may want to have a lot of charging going of EVs and so on happening in the middle of the day to, get at the grid scale duck, but that makes the local one, inverse and may make things worse. So it's definitely an issue that we are starting to tackle. And the catch there is the scale, right? Because you get, all these, 3,000 circuits and even more at the final line transformer level and so on. You need a supercomputer eventually. And, there is one at Lawrence Livermore. We, use that, but yeah, it's a big thing. So we're looking for ideas on that to help us. We do have an existing project, but ideas are welcome on how to do it more efficiently and more accurately. Thanks.
Alicia Farag, Locust View. One of your problem statements talks about the refurbishment and reuse of existing equipment, like when you do upgrades, and can you talk more about that and maybe provide some examples?
You guys are great because you're jumping into the next session's topics. So we're going to come back to that one in the next session. Thank you.
Hi, Marie Washer, energy storage at Tesla. So working on energy storage, there's two types of projects that I've really worked on, behind the meter, like commercial and industrial systems, and then also large utility scale systems. If you have sensor data like temperature sensor, would it make sense to have strategically located batteries that are neither large utility or small behind the meter CNI, but just serve for the sole purpose of managing the load in those cases?
I mean, I think all those ideas would be welcome. I mean, yes, batteries anywhere on the system, if placed properly and used properly, could help alleviate some of the issues we have, right? To basically utilize the existing assets to serve more load. So yeah, I mean, those types of ideas are definitely welcome.
David, any more online?
Yes. This is from Risa Kennedy. Are you using a digital twin of the grid for predictive modeling to understand how to better design upgrades and see how the increased load is handled on the grid, or possible make small adjustments rather than large rip and replace?
Can you repeat that? I'm sorry, I didn't hear it.
Are you using a digital twin of the grid for predictive modeling to understand how to better design the upgrades and see how the increased load is handled on the grid, or possible make small adjustments rather than large rip and replace projects?
So we do closely model, right, all the load on our system and all the requests that we get. And, we always start at trying to do the minimal upgrades as possible, right, to be able to serve that load. We step it up with, what can we do by just simply moving load around between different substations, different circuits, slowly graduate to doing small investments to be able to enable more transfers, and then gradually build up to those bigger upgrades of reconductoring lines, building new feeders, changing out transformers. But any ideas that allows us to do that in a predictive manner, we are open to.
Next question is PG&E, and this is from Eric Schoenman, is PG&E looking at adding microgrid side distributed storage, not customer side, for example, power walls?
So, we have the CMAP and the CMAP program that was recently approved for the distribution system. So we are open to microgrid ideas, right? That's something that, we have a filing at the commission that was approved to do some of that work. So yes, we are we're interested in and open to any ideas around microgrids that could help us serve more load with the same system we have.
Hi, Chris Wycheck with Halo Technologies. I had a follow-up question. One of the gentlemen asked about dynamic operating envelopes. I'm curious, has PG&E investigated some of the successes with that globally, predominantly in AEMO territory with Project Edge, Project Symphony? They're trying to address many of these same thermal and voltage system constraints that PG&E is.
I don't have any knowledge of it myself, but I think we're open to those types of ideas.
I'm not sure if this is the question of the interest of this meeting, but for the EVs, do you envision like this is about the asset planning and basically improvements at the distribution level versus improvements at the charging station level. So do you envision households charging their EVs mostly at their home or at the central charging stations in terms of the cost from the PG&E? PG&E side in terms of the cost of the improvement the grid to basically be able to provide fast charging.
So I think it's going to be varied, right? It's going to be a lot of it's going to be based on what customer desires, right? A lot of it's going to be based on what kind of systems do we design and how do we incent customers to charge at different places or at different times. I think that's going to be dependent on all the programs that we come up with. Right. I think we heard this morning, Patty talking about, right, that belly of the duck. Sometimes we do want to move some load to the middle of the day where we know we have a lot of PV and the charging could happen. And other circuits, it may be better if it happens after midnight, right? And so it's going to all depend on what kind of programs we design based on what our need is. And those are type of ideas that we're looking for to make sure, right, we're thinking of everything while we in the process of designing what this new grid's going to look like.
Online question from Devin Yates. What do we perceive as the primary bottlenecks on capacity that we will encounter first? Is primary distribution equipment, substations, transmissions, everything all at once?
I think the way we look at it, right, we saw the slide on how much growth we're going to have, right? 70% over the next 20 years. It's going to be all of the above. We're going to see issues on the service transformers, on the services, on the primary distribution system, in the substation themselves, as well as the transmission system, right? We look at, supercharging along highway corridors. Most of those corridors in PG&E service territory are rural. We don't have infrastructure, period, right? So we're going to have to build infrastructure. So I think it's all of the above.
One more question. Are you looking at dynamic line ratings or power flow control devices?
We're open to dynamic ratings, whether it be on the transmission system. We're open to any ideas on how can we increase the thermal ratings of our equipment, right? Whether that equipment be conductors, whether it be switches, whether it be substation bus, transformers, any ideas around how we can get more out of the existing assets, we're open to.
Thank you. Hi.
it seems like there's a wealth of ideas and existing solutions for optimizing capacity at both transmission and distribution and planning. It seems to me like the missing link here is sort of regulatory support for deployment of those more, asset light technologies. I'm curious, does that reflect your view, and do you see that changing over the next 5-10 years?
I mean, I think there's always from the regulatory perspective, that always makes a difference. But I think we need to make sure that we get all the ideas there and that we do start optimizing holistically through the whole grid, right? It's going to take the distribution, substation, transmission. It all going to have to be married together to make sure that we're planning for that ultimate load that we're going to see over the next 20 years, which we've seen, heard all day today, right? There's going to be a lot of it, and we need to plan for it. And we got to make sure it's cost effective for all our customers as well, right? That's why we're looking for ideas of what can we do with the existing assets we have today? Can we serve more load? Can we avoid some upgrades, or can we minimize some upgrades, right? We know we're going to have to do upgrades. That's no questions, right? What we're here for is trying to see how can we minimize some of those? How can we maximize some of the assets that we have today?
Sorry, so for maximizing the assets, a lot of, I saw at Grid Tech like a few months ago, they mentioned that utilities and institutes doing IRPs mentioned they quickly go out of date because of how quickly technology is evolving. So has PG&E been exploring some more like dynamic pricing approaches with measurement and verification instead of always waiting for an IRPs, integrated resource planning?
So you're talking more about the power procurement side of the house?
Just giving the distribution side an option to help reduce that congestion on the grid.
I think we'll be open to that idea, but I don't know if I totally get the question that you're talking about. You gonna try it?
That might be in my wheelhouse. So I've been working on real-time pricing rates in the demand flex OIR and CPUC's load management standard. So it sounds like you're talking about dynamic distribution rates, essentially. That is something that we're actually testing already. There is a small pilot at the moment called AgFit, working with ag customers with VCE. Okay, so you've heard of that. The catch there is getting to scale. So we have our good buddies in San Diego did the same thing. They had a Power Your Drive thing a couple of years ago, and they have only a few circuits that they were testing, and they were still pulling their hair out with that. We have 3,000. So at the moment we're looking at it, we want to pilot it more, but getting to scale is going to be really difficult. So we're likely to start with, generation signals as a real-time price, because that's actually that's the biggest signal, right? The distribution costs on average are maybe 20% or something of the gen. So the big bang for the buck is on the gen signal that you get from CAISO and then some kind of a capacity signal. But yeah, we're definitely looking at that, getting pilots going. There's also a VGI pilot that's coming online, I think maybe late next year, that will also look at distribution signals there. And that's open to a lot more customer classes, right? So vehicle grid integration. So but it'll actually be open to customers in a number of classes, whereas the AgFit obviously is just an ag customer, is lots more. So we're looking to get there. And I think the watchword is how to accelerate things. So ideas on that are definitely, appreciate it. Thanks.
Go to online questions.
Online question, how are you balancing the risk of building it twice and underinvesting on the way to your net zero goals? It is great to take a minimalist approach to new network investment, but how do you manage that load is expected to continue to grow? This is from Eli Shakun.
What was that last part? I'm sorry, I missed it.
How do you manage that load is expected to continue to grow?
So, great question, right? So if we do need to, build new assets, replace existing assets, right? When we look at that and we plan for that, we're not just planning for the first 1 or 2 years. We're planning for a longer term, right? We're not gonna change out a substation transformer from a 16 to a 30 because we need 5 megawatts next year. But we got to look at what do we need over the next 20 years? So when we make those kinds of asset decisions, we've actually already started changing our standards to where, like, we go with the biggest size that we can go at that particular location, so that we're anticipating that growth is going to be there and that we replace an asset once, right? It's not the cost of the actual physical transformer that we're going to change out at a substation, right? It's mainly the cost of everything that goes around it, of actually putting it in and all the other infrastructure you have to change. So we want to make sure that we're anticipating the growth over the next 20 years, not just tomorrow. So when we do upgrades, right, we want to make sure that for the dollar we're spending, we're going to get the most bang out of the buck for that.
I'd also add to, I know we're focused on capacity here, but as we are doing our long-term planning, we're taking into account other needs of the system as well as when we're taking into account what work we should be doing. I know we're talking about in the next session about how we can think about planning work a little bit better. But, you know, for example, we're looking at asset health work, assets that may be old or out of, you know, at a condition of where you may want to replace it. We're taking into account those future load growths to make sure that, to your point, we don't go back and touch the same asset multiple times. I do want to point to just sort of comment. I know there's been a lot of like comments and questions about dynamic ratings. Our ask is there anything beyond dynamic ratings we can do on our assets, right? Because I know that's a great solution. Is there more we can do with it?
Another online question. What are the current biggest limitations PG&E experiences when it comes to planning and operation software, optimization software? Are those commercial software programs, or are they developed internally by the organization?
So the current software used on the transmission is PLS CAD, and on the distribution side, right, we use a load forecasting software that's called LoadSeer by Integral Analytics, and then we use SIME as our load flow analysis tool on the distribution system, right? So LoadSeer and SIME are integrated, and we're doing more to integrate them together. However, right, that isn't integrated what we use on the transmission side. Those are some of the things that we need to work on, right? When we say we need to optimize across the whole grid. So we're open to any ideas and that you may have around doing that.
And one other, this is Bill Peter with PG&E, just another thought on that is historically, a lot of those planning software tools have been built around, you know, peak planning, rather than more focused on like increasing utilization of assets. And so the more that we can think through and change our way on focusing on higher utilization. And then kind of building on the earlier point of, you know, the timing of like doing small investments and then big investments and looking out further ahead. Like we know that a lot of these places are going to need major infrastructure projects. And so we want to build for that long-term load. But that takes time. And so in the meantime, we need a bridging solution so that can better utilize our existing assets. So that's why like we need those utilization innovations really in the near term to like help us increase our utilization of our assets.
Question here, Siva Sethuraman with Cascade Energy. So I'm trying to understand, you know, given that there's going to be a 70% capacity growth, how is PG&E looking at behind the meter load management programs like energy efficiency in this whole planning? Because today's energy efficiency programs are created with today's load in mind. And so is there a plan for PG&E to go above and beyond what is being looked at?
Okay, remember I mentioned for I think it was President Stanford about the integrated planning at the grid transmission distribution scale. So that project is specifically also looking at EE and other options to not just controlling load, but also reducing it. But of course, we're also as a part of that, it's not all about reducing load. It's also about electrification. So how can one, electrify California generally in a way that really keeps the loads manageable and, keeps us from having to do all these upgrades. So yes, we are looking at that. Thanks.
And I think the theme here is, right, it's going to take everything behind the meter, whether that's load management, energy efficiency, right? Some upgrades, how can we get bridging solutions, right? In the near terms, while we build the upgrades that are needed, right? All of that is going to be needed. That's why we're asking for help around when we say maximize the use of existing assets. In a lot of cases, that's near term. What can we do? How can we utilize those assets to serve something tomorrow while we're building for down the road? Because it takes time for those upgrades to happen, right? We can't do those upgrades in the substation or on the transmission system, build new feeders. That all takes time. And we need bridging solutions. And some of the bridging solutions could be, what can our current assets do for us, right? Used in a different way, if we could increase the utilization of them.
Hi there. Apoorv Bhargava, WeaveGrid. I'm curious, how have you been thinking about your DERM strategy in particular as it relates to some of the capacity limitations and particularly around dynamic state estimation at the edge? You've got all these new DERs, a lot of them move. That's what my company supports. And so how do you think about, planning and also operating that capacity, as you've got to solve new equations, frankly?
Yeah, if you had been in the earlier session, right, we're talking about DERMS, right? We're in the process of getting DERMS going here at PG&E, right? It's not there yet. We're in the process. It's going to take some time. So we're gonna have to integrate it into our overall planning process, into our daily operations, how we're gonna operate the grid, how we're gonna use that to manage loads, right? Whether it be, fleet loads for EVs, whether it be superchargers, whether it be, school buses, whatever we're looking at, we're gonna have to integrate that in when we have that capability in the coming years.
Do we have an online question?
We do. This is from Ryan Scarborough. How are you evaluating and balancing maximum life of existing infrastructure versus the potential risk from failure of aging assets?
Can you repeat, please?
Sure. How are you evaluating and balancing maximum life of existing infrastructure versus potential risk from failing of aging assets due to outages, wildfires, and so on?
Yeah, so, right, if we have an asset that's not in good conditions, obviously we're not going to increase the rating of that, right? That's got to go, right? When we say we're looking for those solutions to optimize or maximize existing assets, we also have to look at the asset life, right? It could be that we need to prolong an asset. It's going to take some kind of maintenance schedules or different maintenance schedules going forward to do that, right? Until we can replace the asset. But it's not, asset health has to be a consideration as we try to look at maximizing its use as a bridging solution until we can build, right? As we've been talking about. So I think that's all there. That's the whole thing about integrated planning, like Jocelyn mentioned earlier, right? We need to do a capacity upgrade. We may also be helping the asset health of assets that as part of that project, or vice versa. We may have some assets that have reached the end of their useful life. So when we do replace them, we want to make sure that we can also get the capacity out of them at the same time, because we know we're going to need it with the growth that's coming.
Follow-on question from an anonymous submitter. What are you currently doing for predictive maintenance and analytic tools to help extend asset life? And how does that figure into integrated grid planning?
Great question. And I'd ask that again in the next section, because we're talking about that, of what can we do with our assets if we are trying to extend the life. But I would add, though, that extending the life of an asset is part of how you maximize utilization as well. So if you have ideas on that, we would appreciate those.
Last question.
Maintaining existing asset, have you, where do advanced conductors for new builds figure into it, such as transmission lines that can get you 2 to 3 times the capacity of existing, or superconductors that can get you 5 to 10 times the capacity? Is that also in consideration over?
Absolutely. I know we have some of that. It's probably not as 5, 10 times. I'd love to hear more about that. But yes, definitely, because I think recognizing that's part of our conventional upgrades, reconductoring is one. And structures tends to be pretty complicated for us to have to go to replace, whether it's because of right-of-way issues or just the sheer lead time sometimes for those. And so, yes, definitely want to hear about those. I think we're out of time.
Yes, we're out of time with the session. You have 10 minutes for the third session.
Yes, if
So,
you want to hear about
thank you.
planning and reusing assets, stay here.